Hello everybody and welcome to today's webinar. I'm joined this afternoon by Frederick Sverin and Shadid Chowdhury of SmartBear, and they're going to be talking to you today about can virtualization transform your API lifecycle? And if you have any questions for our presenters, please type them into your control panel at any point during the course of the webinar. We have a technical team on hand who are ready to answer any of your questions, so please feel free to type your questions whenever you see fit. So now let me hand you over to our presenters. Hello, Frederick, and hello, Shadid.
Hello. Let me just share my screen. So, welcome everybody. I hope you can see my screen now. My name is Frederick and I am the development manager for the team at SmartBear, developing our solutions for virtualization of APIs.
And I'm Shadid, a senior developer at SmartBear, focusing on developing the service virtualization tool.
Today, there is an increased demand for delivering products to the market fast, but still with good quality. So as we break apart our software to encourage parallel development and to accelerate delivery. And we dramatically increase our population of APIs doing this, but we also create dependencies between software components, the interconnected APIs, and people and teams using them. These dependencies often counteract our desire to go faster. So in the State of API Industry Survey, we asked, what do you think are the top challenges for delivering high-quality APIs? And 1,300 respondents answered that question, and these are the most dominant answers we got back. Increasing demands for speed of delivery. I mean, we already talked about that. Lack of integration between tools, system, and teams. Because with a lot of microservices which can be used by many to shorten time to delivery, the whole business of talking to each other becomes crucial, both because it all must fit together, but also because when other teams are to use your API, it's easy to create dependencies that can break. Managing expectations of different stakeholders. If I produce this microservice to be used by many other teams, how do I ensure that I meet the requirements from all of them and create a sustainable API? And lacking time and or resources due to workload. Because by trying to do many things in parallel, the risk of inefficient use of time due to the cost of synchronization between teams is a real danger. So with increased demand to deliver and do things in parallel, it's easy to end up with a workload caused by the very fact that more people have to synchronize their work to get something done. And seeing what the industry considered their top challenges for delivering high quality didn't come as a big surprise to me when I read the result of the survey. Because it's not a trivial equation to solve, but we believe that virtualization of services can actually change this dramatically. So during this webinar, we will take you on a journey covering the following topics. Some are shorter and some are longer. We will start by explaining the basic concepts of virtualization and how it might be different from the way your organization is used to working. And with that baseline set, we will share some of our thoughts about how we think virtualization can transform not just your testing, but all of the API lifecycle. And obviously, because this is what we do, we have quite a lot of real-world examples where virtualization has been a game changer. We'll talk you through a few of them and give you a better understanding of the meaning of what we explained in the previous section. And finally, because it's important, we will give you some advice about best practices, things that we think are good takeaways, no matter if you're already working with virtualized APIs and services or if you're just getting started. So with us today, we have a few of our experts, both from sales engineering and from my team, who is developing our solutions for virtualization. They are happy to answer your questions during the webinar, so keep them coming.
So before we start getting into the main topic, how virtualization can transform the API lifecycle, let us briefly explain the key feature of virtualization and how it helps to remove the technology constraints. So you are all probably familiar with mocking, right? So virtualization is like mocking, but it's much more powerful. So shortly, I'm going to mention a few of the desired features that make virtualization as a powerful tool for the users. So first of all, virtualization easily allows you to add non-functional behavior. So in case of API virtualization, you should be able to add latency, delay, congestion, which happens sometimes when you communicate over the network. So for example, think that your service is dependent on external service. Maybe it's calling some bank's API, which started responding really slow during the peak traffic. But you want to make sure that if that happens, your system can handle that situation without choking or breaking apart. Also, when this happens, does it show some useful, meaningful message to the user? So I mean, people doesn't get surprised what's happening. So these are normally really hard to test scenarios, but these are likely to happen occasionally. And virtualization makes it easy to reproduce these scenarios. So being able to easily play and control the non-functional runtime behavior is a big plus. Secondly, when you are doing API virtualization, your virtualized APIs are usually accessible as a service, making them available to different teams, different tools or programs. In comparison, when you are mocking, it's likely that it runs and it creates the mock as part of your test, and once the test execution is complete, mock is no longer available. But virtualization makes the virtualized API accessible whenever somebody needs it. Someone just needs to create it once, and then it can be easily reused. So this saves a lot of cost by saving you from duplicate work and effort. So in our view, another plus with virtualization is the increased accessibility and availability.
Yeah, one of the best things with working with tools for virtualization is probably the ease of creation. A good virtualization tool should allow you to create verts, as we call them, from your API specifications. And it could be whistles if you're working with SOAP, or it could be YAMLs or Swagger definitions. But as we all know, API specifications aren't always there. And even if they are, they could be in an odd format like PDF or HTML or even printed on paper. So the tool should allow you to record actual traffic and create the virtualized service from that. So using the recorded data in your response when people call your vert. And this is not just a good way to get your virtual API set up and ready to go. It's also a really good way to find out how your existing software is using your old undocumented services. Many of you have been in a situation where the organization wants to replace an old service used, but no one really knows how much of it's being used, and you really don't want to break something people are using. So finally, virtualization allows you to do some really powerful configuration, which otherwise would have taken a long time to implement as code. For example, you should be able to hook in a data source, like an Excel file, to make your responses more dynamic, return different things every time. You will be able to configure which responses are handled by the vert and which one who will be relayed to a test server, and which have the real implementation. And we'll talk more about that later. It's called routing. And all of the above makes virtualized APIs a real productivity boost in comparison to mocked services. And all these features that we mentioned makes it possible to create a virtualized service within hours without writing any code. So how about transforming API lifecycle with virtualization? I'm sure many of you have already got ideas about what it means for you. So let's move on to that topic. But before we start talking about transforming the API lifecycle with virtualization, let's stop for a while and talk about what defines the API lifecycle. What is it? Well, when we talk about it, this is the major building blocks. Obviously, you need to start with designing and defining the API. It is usually an iterative process. Maybe you're already using tools for collaboration like Swagger Hub or something else. And once you're done with the design, it's time to start building it. Bring in the devs. In this block, it's very important that you realize that your design for the API is out there, and it might actually be used by others already. So stick to your API definition. Quality is of course important for us and for our users. So as you know, testing is really important part of that lifecycle. In agile organizations, many things in this block happens as part of the previous block. In other organizations, this block might be happening as a next step. And finally, when the API is up and running, monitoring it is key. Because not only do we want to be alerted if something starts failing or misbehaving, our API consumers could be an app or a website, in which case the users will not understand that the problem is not the app or the website, but something underlying. Being unresponsive is bad, but causing others to be unresponsive is often worse. So to make things faster and better, we need to shorten the lead times between the blocks. For most APIs, the lifecycle repeats itself, and the API will evolve as we develop and release new versions of it. And then we start all over, not from scratch, but all over. So if we look into them, I start with the design. You have decided to start building a new service. Or maybe you're just making changes to an existing API, and the goal is to roll out a new version of it. This process usually starts by doing some sketches about the API and discussions with the teams and the stakeholders to get opinions from experts and users. It's rarely something you do just once before you start building the perfect API, but rather an iterative process where you do it a few times. How can virtualization help here? Well, maybe your organization is building a smartphone app or a website. You can now easily create a virtualized API from your WSDL, WADL, or Swagger. Or you can just build it from scratch by defining the operations and endpoints in the tool. With a virtualized service in place, the ones who are going to use the API, they can start building a simple prototype to test the design. And this design we sketched up in the first step. So, even better, the people who are going to use the API, they can not only test it, they can taste it and come up with early feedback to improve the design before we start spending resources to write code. And being able to do this as part of your iterative process for designing your API without having to write a single line of code to implement things on the API side is a fantastic help for you. The early feedback and the early validation can, or well, let me rephrase that, it will save you a lot of time and resources at this early stage. And maybe even more important, it will help you create better APIs.
So once you are done with your design, you want to go and actually build an actual API you have designed. So you build API so that someone can use it to integrate with your system. Maybe there are other teams, customers waiting to do the front-end work based on your API, or it can be other way as well. I mean, the service you are building depends on some other API that is not done yet. So looking at in a more traditional organization, you would build the API, and then once you were done, you would test and integrate the API. But we all know that dependencies often further delays things, since sometimes, I mean, you discover issues at the very last moment. But in this scenario, virtualization can be a real game changer. With service virtualization, you can avoid the dependencies, preventing you from development work. You just need to virtualize the API once. And once the specification is ready, you go and virtualize it and talk to the virtualized API until you get the real thing. So with the help of virtualization, you can actually test early, integrate early. So once the API specification is ready, testers or anyone in the team can create a virtualization. then based on that virtualization, you can actually create your test cases. So once the devs come up with the first version, they can just you can just switch the endpoint and play the run button and immediately run a bunch of test cases against it. This is otherwise, sometime would have taken months to develop. So this allows actually working in parallel, and it also supports cross-functional team. So getting one step further, virtualization can help you also with continuous delivery. So as you complete feature by feature in the API, you can deploy it in a real test environment and configure the virtualization to route the incoming calls to the real test server instead of like returning the prepared responses. So this enables you to do continuous delivery, and both the consumer of the API or maybe the QA can start working with the real thing as you deliver it. So you don't have to wait months for the devs to complete the implementation. And again, it's for both producer and consumer of the API can work pretty much at the same time. And time-wise, this is a big gain. So the key point here is with virtualization of your API, you can actually save a lot of time and resource, and it will also save you from probably last-minute surprises. So with virtualization, you can actually left shift the whole release cycle, and it really helps your organization to go to market faster. So coming to test, even though API testing itself is really just a subset of the quality, but it is very important and it is very critical to the overall quality. And API testing is not only about functional testing, it's also about performance testing, security testing, and all the non-functional behavior that you will face while you communicate over the network. In addition, your implementation is probably dependent on many other microservices or API. So you also want to make sure that your API is resilient and isolated from those external failures. So let's get into a bit detail how virtualization can help you in different aspects of testing. So first of all, think about the performance testing. While you were doing the performance test of your implementation, you want to make sure that the dependent services or maybe the third-party APIs are sending responses according to their expected SLA. So you can actually pinpoint if there is any problem within your service. Virtualization helps you to take away the problems caused by third-party services from the equation. So you can isolate the problem and just focus on the performance of your implementation. So in contrast to performance test, virtualization can also help with the non-functional testing. In real life, services you depend on might go down, they might occasionally become slow, so you also want to test the resilience of your system by having virtualization with those behaviors simulated, like delays or service not available. So with service virtualization, setting this up is just a matter of configuring your virtualized services. And same goes for security testing. With virtualization, you can easily create negative scenarios for your authentication or authorization service and make sure your service is secure. It could be that the login service or credit card transaction service simply not letting you or not returning the incorrect set of credential. Or you can just virtualize the response of your auth server, returning all different edge cases and negative responses to make sure that you get your security covered. So in summary, with virtualization, it allows you to easily do performance testing, security testing, and non-functional behavior testing, which is other way would require probably a lot of time and effort.
Yeah. And finally, monitoring, the last block of our little graph of API lifecycle. So what about that? How does virtualization play a role here? Well, once your API is delivered, you need monitoring of your API. You probably have tools already for making sure that all your systems are up and running and performs well. Virtualization affects this area in many of the same way it affects your quality assurance. Because with a virtualized service, DevOps and others can start preparing for the real thing, setting up monitors, preparing and test alerts long before the development team is delivering anything. And they can use that virtualized service to shorten the time needed after the release to get it up and running. And this is possible because the virtualized API is a really good simulator for the real thing. And so with the addition that it's not just simulating it, you're able to ask it to misbehave in all possible ways, like, error codes, latency, delays, as Shadid just explained for testing. All this to make sure that your monitoring software can alert you of failures. Without virtualization, you wouldn't have been able to really try this out until the developers had at least sent you a pre-release stable enough to play around with. So, as you can see, virtualization can really be utilized throughout the API lifecycle, and we believe it can truly transform your API lifecycle as well.
As promised, we're going to show some real-life examples of how people are using virtualization today in different ways. And we have chosen like 4 customer stories that we'll share with you one by one. So we had a client with a very complex setup. Their setup is even further complicated than what you see in the slide. So they have legacy systems, they have services with XML, RPC, REST and SOAP API, all you can think of. They have legacy systems, for example, doing accounting, user management, and also they have some relatively newer systems doing other things. So on top of that, they have also created an API gateway to funnel all the external requests. But some of the internal client can also directly access some of the API, making it even further more complicated. So it's not an ideal scenario, but I guess some of you are here probably familiar with this kind of complicated setup. In addition to that, most of the systems has a database layer, and these systems all are interconnected to each other, and most of the systems didn't have any API specification. So setting up a test environment for this kind of environment is like a really long, painful process. It required them to install the latest build on test server, and they had lots of manual scripts for inserting the test data. And every time somebody needs a fresh setup, it takes almost half a day. And still with that setup, that test setup, it was really hard to generate some of the error scenarios which happens in production. So they have used our virtualized solution, which has both routing and recording capability. So what it does is it routes the request to a test server and adds the responses to the virtualized API. Or, depending on how you configure it, it can also simply answer from the pre-configured responses. So with that recording and routing feature, the virtualized API itself learns the request and response pair. So using that, eventually they were able to manage to create Vert for all of their systems. And eventually they had some customized request matching logic, and they also hooked in some external data sources so that their virtualized APIs are more close to the production. So now, after that, people from different teams can look at the available virtualized APIs and run them like within minutes and orchestrate them and run their test against it. And this saved a lot of time and effort, and also made them like to test really what they wanted to test. So we have another customer who ships physical devices, and the firmware actually contains the API. So to do the integration testing with their machine, they needed to update the firmware with the latest build. And every time a feature is completed or maybe a bug is fixed, they needed to build and roll in the firmware update and test against it. So sometimes the changes made by developers, it doesn't work, so they have to roll back to the older version, losing 3 hours of development time. So to overcome this problem, customers started using the dynamic routing feature of our solution. So in front of the physical machine, they put a virtualized API which can dynamically route to both physical machine and to their test server, which has the latest build. And the routing is configurable simply with few clicks. So this enabled the team to change their workflow and become much more efficient. It saved them like days of productive hours. So now they can avoid the process of firmware update when it's not necessary. So going to the third story, we have another interesting company or organization which recently started using a service virtualization product. And that company has deployments to thousands of customers. And each customer has a combination of product configured for their development. And for integration tests and or a bug they want to reproduce, it takes a lot of time and effort to recreate the customer settings. So when they're updating the customer deployment, for example, it takes huge QA effort to set up the customer environment. And even the test environment is not accessible to everyone. So if QA finds an issue, sometimes it takes few cycles to fix it. So with our virtualization solution, they were able to set up customer scenario very easily. So instead of deploying a real test system in test server and adding test data, they were able to virtualize the customer settings with edge cases and like negative responses and all the different customer settings that customer actually have. So once they have done it, it was really easy for them just to reuse it next time the same customer came back with a problem, or maybe they just wanted to deploy a new version, so they could just reuse that virtualized API. So this saved them a lot of time and effort in doing like which otherwise they would have been doing like repetitively in a manual fashion. So also the verts are available to different teams, which reduce lead time and the release cycle. And the QA department became much more productive at the end.
Yeah, the final customer story I'm going to share with you is about a company that has a very popular physical device. And it's getting more and more common with APIs there as well in this age of Internet of Things, IoT. And there are a lot of third-party vendors using the API here to build apps and services around the machine. So for those vendors who wanted to integrate their services or build apps on top of the API, they needed to get hands-on the actual physical device before developing. And this presented them with a lot of logistics problems. Because if you want your software to work when the new model of the machine is launched, not only do you need to get hold of a pre-release machine, something which includes, well, getting one, but getting it in place on location and the whole waiting for it to be delivered and configured. So, and then in case there is an upgrade of the API or you run into bugs which needs an upgrade to be fixed, something which is actually quite common in pre-releases and betas, the customer had to wait for a technician to come on site and upgrade it. And also the vendor will have to ship enough pre-release units to satisfy everyone developing apps and services for it. And that in turn can eat up resources from the production of the actual product and its APIs. Well, and then of course, most of the time when you're developing and you're talking to machine, you really don't need the physical machine to produce things during development. So in short, it just didn't scale very well. So by changing their whole model into using virtualized APIs, the company can now satisfy the needs of many of the third-party developers by giving them access to virtualized API instead of the physical hardware. So you no longer need to ship a lot of machines and deal with sending technicians to the third-party developers just to upgrade firmware on a pre-release machine, etc. Much of the development can be done talking to the virtualized API. And that is a model that scales.
So before we end the presentation, we'd like to share a few best practices when it comes to service virtualization. We'd mentioned a few tips that might help you to take the full benefit from your virtualized API. So first is like having unhappy path or negative scenarios. So when you are creating your words, make sure it contains negative scenarios, because we all know when developers test, what do they do? They just focus on the happy path. With virtualization, it is really easy for you to create negative scenarios, and you should really use that to make sure that your system works well, even when it gets negative responses. So when you build a microservice tests, it's not only to prove that it works when you get positive responses, but it also can handle when it doesn't get the desired response. So for example, maybe your product or API is using another API which provides a credit check facility. When creating the Vert, you should create 2 test persons, and one with good credit rating and one with bad credit rating. So when you call the virtualized API with the person with bad rating, it should return a negative response. Or maybe just it returns a person which doesn't exist or something like that. Or just think about extreme scenarios, which is normally really hard to reproduce. Like you have built a weather application and you want to return the extreme conditions like minus 50 degree or plus 50 degree. With virtualization, it's really easy to do so, and you can test those negative scenarios. So, I mean, it allows you to take the full control over your test, and you should really utilize it. And the second thing is your Vert, you should have runtime behavior simulation. So just to make sure that your microservice is isolated properly from the external failures. So because in real world, nothing is perfect and no one claims 100% uptime. So even though services will go down rarely, you need to make sure that when this happens, your microservice can handle it. You want to introduce delays, occasional failures to test how can you, your test system can handle it. Does it choke when it's not getting responses in time? Again, developers are really bad at testing those rare but likely to happen scenarios. By adding runtime behaviors to your virtualized API, you can make sure that this happens. Maybe you want to simulate that your server is unavailable, and with virtualization, it's really easy. So you should also consider that. Getting to the third tips, you should always focus on integrating your Verts with your build and release cycle. So once you have created a Vert covering different scenarios, you would like to make sure that Verts are integrated with your build and release cycle. This would make sure that you have more predictable tests, better coverage. Having Verts, for example, with canned data simulating responses like real world helps a lot to improve the overall quality of the product and overall your testing quality. And this is a much cheaper alternative to building a test lab with production-like data. And finally, to take the most benefit out of your Verts, you need to make your virtualized API available and accessible to everyone. If your Verts are in a version control system, it will make it easier within the organization to find it and reuse it. It should be as easy as just pulling a Vert from Git and spinning it up within seconds when you need it. It's also a good idea sometimes to host the Verts in a server which is accessible to everyone. At the same time, it should be easy for you also to be able to pull the Vert from the server so you can run it locally and still work. For example, maybe when you're traveling on a train and you don't have a stable internet connection, but you don't want your work to be disrupted. So make it portable, make it available and accessible. These will save a lot of time and effort. It increases the overall productivity of the organization. So to summarize, make sure your Verts contains negative scenarios. Make sure that you add network behavior or non-functional behaviors and integrate it with your build systems and make the words easily available and accessible for everyone within the organization. So presentation-wise, that was our main content, and we have some links if you want to find out more information about our virtualization product. You can follow the links. We also have a collaborative API designing tool available at Swagger Hub, which we mentioned earlier in the presentation. Using Swagger Hub, you can design your APIs, but it's also a really good way to get your API documented. So now that's all from us, and we'll hand over it to the host.
Thank you both very much for your presentation. I'm just going to open my screen again very briefly to go through one or two slides. So coming up very soon is our early bird deadline. So if you'd like to attend the EuroSTAR conference and you book between now and the 18th of September, you can avail of a 10% discount on your tickets. We have some more webinars coming up this week. We have a webinar taking place tomorrow, which will look at 5 digital aid trends that will dramatically impact testing and quality skills. We also have another webinar coming up at the start of September, which will look at continuous testing, the key to increasing delivery speed and quality in your DevOps pipeline. And we also have a webinar series that is taking place in September with a lot of the big name testers there. And if you'd like to find out more about these webinars, just follow the link here. I'll share with you. It'll link you to our webinar schedule. And if you have any other questions, I see you've been adding questions during the course of the webinars, and thanks to the technical team there who've been on hand to answer all of your questions. I have one or two other questions that have come through here as well that I might just relay to our presenters. And the first question I have here says, what do you mean by routing and virtualization? Can you explain that a little more?
Okay, so routing, it's you can think of it as a like proxy. So it allows you to forward the request maybe to your test server. So for example, when your API is actually ready, so instead of returning the prepared response, you maybe want to get a virtualized API to go and fetch the response from the test server where you have deployed the real implementation. And also it has the routing capability, or like with configuration you can decide which request to route and which not to route. That's why we call it routing feature. But it's like, think of it as a proxy with routing capability.
Yeah, and also the extra powerful thing there is that you, as Shadid mentioned, it's configurable so that as your agile development team is delivering parts of the product, feature by feature, you can turn off or on routing for those specific features.
Yeah. So that's pretty much it.
Anything else?
Another question here as well that asks, how easy is it to integrate virtualization with the build process?
Interesting question. Well, it depends on the tool, of course, but as we explained, with part of the idea with having virts deployed on a server and have them available to not just the actual testing script, but to all of the organization, chances are that your virtualized service is actually running all the time, and then you don't have to do much at all to integrate with it. But that's not always the case. So it could be that you want your own private virt set up as a step in your build process, and depending on how you do your builds, it could be you can achieve that with a Maven plugin or a Jenkins plugin that either starts or stops your virt when you start and stop your test steps, or even deploy the virt. I mean, it could be part of the thing you're working with. So typically we would deploy, start, and then tear down the virt when your tests are completed. And if you don't have a Maven plugin or Jenkins plugin, or we're using a build system where you don't get the plugin architecture, then using a script is probably, in most cases, is another good solution for it.
Yeah. Also, maybe sometimes you just want to run your birds in a test server or some other dedicated servers and answering the test requests. That can be also another way.
Okay, I think that's all we have here in terms of questions for now. I see there was a number of questions that have been addressed by the technical team, the back end, so thank you guys for that. I'd like to thank our two presenters today, Fredrik and Shadid, for taking time out to present this webinar, and which has been recorded as well. So if you'd like to view the recording, just head over to Huddle, and you can also access the slides. So that's it from us, and thank you all, everybody, and take care.